guys, slow down. It's not that exciting, but it really is. Welcome to the Cam Show. In this exciting episode, you will be learning about the 3 laws of motions and what they are and what they do. We will be doing household examples that you can do yourself at home. So for all the examples today, we are going to be using Newton's laws of motion. Newton's laws of motion are 3 physical laws that together laid in foundation for classical mechanics. They describe the relationship between the body and the forces upon it, and its motion response said to the forces. So in that example, we will be giving the 3 laws of motion and giving examples for each and every one of them. Alright, so let's start off with Newton's first law. Newton's first law states that the body at rest will remain at rest, and a body in motion will remain at motion, with a constant velocity, unless acted upon by another force. This law is called the law of inertia, and I am today going to do a knife and the apple. I'm going to take the knife and the apple. I'm going to be placing it right here in front of the table. I'm going to kind of push it a little more upwards because, you know, I need to get the example in. So I'm going to put it right here, and this is in motion. The apple is staying there. It's going to remain there and not be in motion. But the knife, however, I'm going to be using the knife and pushing it down on the table, like now. It went down the knife. As you can tell, I put it right here, and now it's right there. The motion that it acted upon moved with its constant velocity. So I will be now showing you again what I'm meaning, just in case if you missed it the first time. So as you can also do it once again, I'm putting the apple more up here on the top of the knife. See? Right there. And if you hit it on the table, see where it's gone. An act forced upon by an outside source moved the motion of the apple. Newton's second law of motion. The acceleration of an object as produced by the net force is directly proportional to the magnitude of the net force in the same direction of the net force and inversely proportional to the mass of the object. In English, this basically means that if I move a bigger object compared to a smaller object, the one with the lower mass will move faster and more efficient than the bigger object. Alright, so in this example, I have my very special guest, my sister, Madison Hadley. We will be using one big object and one small object, and we will be pushing them at the same force. In this example, we will show you that the smaller mass will move faster than the bigger mass. We will be using this rocking chair demonstrated right here in this box. We will be pushing them at the same exact force as each other, and we will see that this box will move faster than this chair because of the less mass and the force, which is the same exact, let me conclude, that we are going to be using. Ready?
Set, go.
Remember, push it at the same force.
Got it.
Stop. Alright, and if you'd please move out of the way. As you can tell, Maddie and I used 5 seconds of our time, and we raced our objects. We used the same exact force and went the same exact time. We stopped at the distance that we wanted to stop at from the box over there for an example. I'm not sure if you can see it, but it's there. We stopped there, and clearly the basket is farther, and it moved faster than the chairs. Finally, Newton's third law of motion. In Newton's third law of motion, for every action there is an equal/opposite reaction. Now onto the example. My sister and I will be chest bumping. 1, 2, 3. Alright, well that concludes the end of the Cam Show. I hope you all enjoyed the pure essence of this video, and hopefully you learned to do some pretty fun things at home with the laws of motions. But it's not just at home either. You see it all around everywhere. Every step you see, just think, hey, some dude on the basketball team just chest bumped me, or I accidentally stabbed my apple with a knife. That's definitely the laws of motion, guys. Be sure to always look out for them, and it's all around you. This concludes my video. Thank you.